Okay, so it says GH is a midsegment of DEF. So GH right here is a midsegment of DEF. So with it being a midsegment, it hits at the midpoint of each of those lines. It's parallel to the other segment, and it's also like half of the length of this segment. Just we're going to need to know that in a second. And then it also says that DE right here is the midsegment of ABC, this triangle. So again, it hits at the midpoint, it's parallel, and it's half of the length of this segment here. Okay, so it says if GH is 1.5, so I'll label that. If that is 1.5 centimeters, what is the length of BC right here? So it's kind of like a puzzle. We're just going to look at the different pieces and then see what we can figure out. So if this is 1.5, it's half of the length of this. So we can do 1.5 times 2 to get the length of this. So 1.5 times 2 is 3. And that's how we can get that. Then if we have that mid-segment corresponds with this line right here. So this would be half of this length. So we can do 3 times 2 equals 6 to get the length of this. So BC equals 6 units. Or centimeters. It's in centimeters. Okay, the next one, it says two sides of a triangle measure 24 inches and 29 inches. Write an inequality that represents the range of lengths for the third side. Okay, so in a triangle, the sum of the two shortest sides must be greater than the third side. So like in a triangle, if the two shortest sides are added together are shorter than the third side, it won't reach and it won't create a triangle. Also, this says write an inequality. An inequality is a thing with a greater than or less than symbol, so that's what we're going to be writing. And so yeah, so the way we figure this out is we take these two lengths and we subtract them, and then we also add them. So 29 minus 24 would be 5. 24 plus 29 is 53. So the third side has to be less than 53 and greater than 5. So this would be the inequality they want as the answer. So kind of making sense of that, if you had a triangle and let's say 24 and 29 are the longer sides, and then this right here, this has to be greater than 5, so like 6. So 6 plus 24 would be 30, and that's greater than 29, so it would match. Obviously, what I'm drawing here isn't to scale, or if like 24 and 29 were the shorter sides, this would have to be 24 plus 29. 53 has to be greater than this side, so this could be like 52, but it couldn't be 53. Makes sense. Anyways. Okay, and then this one here, Wednesdays, it is a proof. Now with proofs, there'll always be like a drop down or like multiple choice, so you won't have to think of reasons out of thin air, which is nice. I'm going to go through like the situation and then let you figure it out from there. So the situation is, it says given that AB is parallel to CD, so it's saying this is parallel to CD. Cool. It also says that AD is parallel to BC, like that. It wants us to prove that triangle ADC, is congruent to CBA. So we're probably going to have to use like side, 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 side angle, side, something like that. Angle, side, angle, something like that. So first of all, it says that angle BAC is congruent. So it puts the given in there. I guess that's first of all. Then this statement here, it needs a reason. It says that BAC. So what I'm going to do is mark this. BAC right here is congruent to DCA. So it's saying these two angles are congruent. So with these being parallel lines, this is a transversal, and you're looking for the relationship between those two angles there. And then it also says that DAC right here is congruent to BCA right here. And again, you're looking for the relationship between those two angles with the parallel lines and a transversal, because parallel lines this way and a transversal this way, there would be a relationship there. So that's what you're looking for reason number 2. Then it says that AC is congruent to itself, and it says reflexive property, which makes sense. And then for this, for the congruence, you're looking for whether it's angle, side, angle, side, angle, side, angle, angle, side, or side, 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 and then filling that in there. So I'm going to have you try this by yourself and go around to check and keep track of who gets it right and who doesn't. So go ahead and try it out. And also, if you could like write out the answer instead of just putting a letter, that would be good too. Okay. So we have alternate interior angles, so that's why we put that. Then it says AC is congruent to itself. And then for the last part, we're looking for whether we have angle, side, angle congruence. So you're looking for like matching angle, side, 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 angle, side. And I see angle, side, angle, and angle, side, angle matching on both. So that means that this would be angle, side, angle, congruence postulate. Okay, and then the reason why as well, some of you put like definition of congruence for this. Definition of congruence is when like you have measure of angle A equals measure of angle B, and then you can say that angle A is congruent to angle B. So it's going from measure is equal to congruence. That would be definition of congruence. Or sometimes you'll see it as like length of segment MB is equal to length of segment CD, then you can say that MB is congruent to CD. That again is definition of congruence. So that doesn't really apply to this. They're more looking for the relationship between the angles. Some of you would put vertical angles theorem. Vertical angles would be like opposite each other with intersecting lines. Those would be equal because of vertical angles theorem, but that's not the situation that's happening here. And then corresponding was the other answer choice. It's corresponding angles. That's when you have corresponding angles like this, like these are corresponding. So that would quite apply either. Any other questions that you thought in your head as we were looking at this? Okay. Okay. So go ahead and pass this up. I'll collect it. Good job. And we'll move on to the next bit.